Good morning. Today we are doing a whole bunch of stainless. Some of it is Waterjet cut. We have a saw cut piece here. A lot of it is punched. And some of these internal contours from the punching have quite a bit of burr, especially in the transition between the punch hits. So we have two levels of abrasives that we can try, and we have pretty much two parts of each, and we are going to run each either with our standard block, which is a mix of abrasives and Scotch-Brite, and then we are going to switch over to this new abrasive that we have, which is a solid abrasive, no Scotch-Brite in between. It is a little bit shorter and therefore more aggressive. It just has a lot more abrasive on the block than this type of a block. And then you can see the difference in your edge rounding and in the burr removal and whatever is more important for you. And we will mark those. If we use this block, we will call this semi-block, and when we use this block, we will call this standard block. So the DM1100 is straightforward as always. High friction conveyor belt to hold small parts. The conveyor belt moves up and down to make material thickness. Here are your blocks. They are on the upper carriage. That moves up and down to make the grinding pressure, which is set very easily. Change the belts. We have a quick release here. You open up the guard on the bottom, you take the belt out, put the new belt in, and then you tension it again. And you have one belt in the front of the machine, and then you have a second block counter-rotating in the back of the machine. In the front, we grind right to left. In the back, we grind left to right. So here we go. To turn on the machine, all we do is we turn on the main switch on the right side, and then we can set for the thickness. We will start with the thicker materials here. With the, I'll start with those Waterjet parts. This is a burr side, and this is a top side. So all we do is we set really quick for material thickness, about 3.4 here. And then we turn on the conveyor, we turn on this. And we run the belt until here and here. And because it is stainless, we're going to go slow. We're going to go about 2 feet a minute on the burr side. At 2 feet a minute, you are still going to run about, what is that? It will take about 20 seconds, 25 seconds for a part to disappear in the machine. And if you look at it at that angle, you could place 1, 2, 3, 4, 5 side by side, somewhere in that. So it would be 6 parts per minute or 360 parts per hour, single side. And then so here we have the part coming out, and it looks excellent. I think you will really like those edges from the Waterjet cut. You see the mark on the conveyor belt, which means we remove material. You see what it does to the surface, and you see how the edges work. Okay, so of course very aggressive. So I'll mark this. This is a dross side. And it is our standard block, which I'm going to call SB, simply, and it was 2 feet per minute. So now on the non-dross side, we're going to go to 3 feet per minute so that we can see that too. Only we make that here on the dial. And you can hear how the blocks engage. And we go from there. And right away, since we're doing the same thing here, we are going to run the little part, so you can see that through. It's the same thickness, and I would use the same parameters for that. So here comes the part, and again, it's a standard block. feet per minute. And that's the non-drop side. And the same goes for this one here. Standard block, non-drop, and 3 feet per minute. And then we're going to, you see the part didn't move. It was sitting right here. And now we're going to change the bird and run the bird side again. We're going to slow down a little bit to 2 feet. So the standard block for your Waterjet part works very well. You have good balance between inside contours and outside contours, good deburring. I think you will really like those results. Then we're going to move on to the punch parts, which are a little bit harder because they have more drop. And this is where I'm worried that probably this other belt will perform better than the standard belt. So, same thing. This is the draw side. Not doing very well riding here today. Draw side. And standard block, 2 feet per minute. Alright. Now, like I said, we'll go to the punch part. Here we go to the 2.5. All you need for the thickness change, I'm going to stay at the 2 feet per minute. I'm just going to change the thickness to 2.5, which is a small crank on this, which is basically for 12 days, 2.5 millimeters. And we're going to keep everything the same. I'm going to lighten up a little bit on the brush so that we're not too hard available. I'm going up about 20,000, not too much. And here we are not going to mark the draw side because on a punch part it's obvious which side the draw side is. And what it will not remove your tab, obviously. If you want to have tabs removed, you need to grind that by hand. So, the edges are nice and smooth, right? That worked actually pretty good. So that was 2 feet per minute, standard block. A little bit more room, we can ride a little bit more. And then we do the same thing. I don't know if you wanted us to do this side, we'll do it just so that you see the surface. Of course here everything is super round, so we'll go 5 feet a minute. At 5 feet a minute, of course, the part appears a lot quicker. Now you would be running about 700 cars per hour of part this time. So, everything is nice and rounded in here, including the tab, so that is 5 feet per minute, but I don't know if you even intend to ever run this side. It could be that you're not. Wouldn't be required, right? And this is a standard block again. So, now we come to the part that is a little bit more difficult, which is, hang on, we'll go down in the thickness. You see this has a bow, so it'll grind a little bit harder in the middle than on the edges. The belt will keep it down and things like that. A bow in itself is not a problem. I'm not even going to change the thickness for that, I'm just going to run it as it is. And of course we will slow the bird side. So the very beginning of that part may be a little bit undercooked. Yeah. So that is that. And then we are going to run this one. And I'm going to do that, but for that I will change the material thickness. And again, ease a little bit on the block. So, this is standard block. 2 feet per minute. And that's the draw side. On the front part you can see that. You see, I like those edges. There's nothing wrong with those edges, and I think you will too. It's just a little bit where your tabs are, where you feel it, but you can't cup yourself, right? So, and again, we'll do the top, but we will, oh, there's one thing. You have on your front parts, you have a lot of oil. You want to wipe this oil off because that oil would go into the brushes and it would contaminate the brushes over time and make them far less effective than they are when they are nice and dry. And again, you will run at 5 feet a minute. And you can almost still read that. It's very faint. I'll just repeat it for you. So, that's completing this. Now we'll tackle this one. So for this one, again, we'll go up about a half to this one, and we will come all the way in for the thickness, even though holding wouldn't be a problem. So to give you an idea how long this goes, what I do is, on this one you could run 1, 2 side by side, almost side by side, depending on which angle you run. So, and if you take the time, how long it runs in, again, we'll go slow, 2 feet a minute. So that's about 15 seconds now. And you can see that on the video also, on the timing. That's about 30 seconds. Seconds. 50 seconds. So about 2 a minute on one side, which would give you 120 of those parts from the burr side per hour. 2 feet seems very slow when you make samples, but really in reality, if you look at it, it's pretty quick compared to hand deburr. I don't think you could deburr 120 of those by hand. So the edges are pretty good. You will have a little bit less on the inside contour. On a thin part like this, you have a little bit of conveyor rubber from the conveyor on the part that you need to wipe off. And I will write from you. So this was a standard block. And it was 2 feet per minute. And this is the draw side. You can see how quick the machine is adjustable to the different parameters, and the top is going to do it 5 feet again, which is quick. And And then the next thing that we're going to do is we're going to set the machine up for these Waterjet parts. And again, they have very little dross. I think I'm going to run this at 3 feet and 4 feet a minute so that you can see that. It's 9.3 millimeters. You see how quick we can change the machine between the different thicknesses. That's not a problem at all. So, changeover. This is one of the great features of this machine. So all we do here is we go, you heard it go quiet, we go to the material thickness, right? And then we can give it a little bit more again, not too much because it's a pretty small part. And we are going to run at first 3 feet a minute on this side. And then we're going to run at 4 feet a minute on the other side. Of course, in thick materials, the machine runs a lot quieter because you're not in the conveyor belt. You're going to be in the conveyor belt with material 12 gauge and under. 12 gauge very lightly in the conveyor belt. Then the other one a little bit more. The conveyor belt is a consumable, I would say about $2–3 per hour. Materials like you have. Here comes the part. As you can see, it didn't shift. Super nice edge in those thicker materials. So that is 3 feet per minute. Standard block. Right? And then we're going to run the other side at 4 feet per minute. Tell you what the bird side is. You probably can see that. You notice how I put the part on there, open to the inside so that we don't run over the corner parallel. It gives you a little bit better result. So we're going to run this at 4 feet. And you're going to run you're going to run more than 1,000 pieces of that per hour. I know you don't have those quantities. If you were to gauge how, what the capacity of the machine is. Here we come at 4 feet a minute. Standard block. Right? Okay, so these are these. So the only thing that's left to do for us is this one, which is a saw cut piece, and I'm not really sure which side you want me to run. So I'm first going to go and start with this side. So this is 9 feet there. And again, we're going to run 3 feet a minute. And I'm going to run 2 sides with the standard block and 2 sides with the other block. And I'm not super comfortable picking this thing on the end, so that's going to be a little bit of an experiment. So that's still 4 feet a minute here. And that's done with the standard block. And we're going to run the narrow side. I'm putting this at an angle so that I never grab the whole part by the side. It's always this way, the blocks are combing. It's not going well. So what we did here is I completely forgot to set the height to the 25.4 millimeters. This is why you see this massive edge rounding. And then I shut the machine off because I heard it and I saw stuff flying. So this is super heavy. Yeah, I can't fix that anymore right now. Standard block, but you see how forgiving the machine is basically, even for something like that. Standard block at 4 feet a minute. that was a demo of what you are not supposed to do, obviously. So I apologize for that. So, that concludes all those parts. For now, what we are going to do next, we are going to cut the machine off, and I'm going to show you a belt chain on one side. The machine also shuts off when you open the door. To do a belt chain, the first thing that you want to do is you want to bring the belt all the way up so that you can get it out easily. The further you bring it up, the easier it is. Then you open these, you take the guard off, give these a couple more turns so that it goes on easily afterwards. Leave those pointed up and pop this out of here. You bring this back forward and drop the belt on the right side and you lift it up. Then you take a new belt and you lift it in. I'm sure that you have seen that on the original video from NS also. Bring it over this roller. If you tighten that roller a little bit, it's easier to put it on the guard in the back. So, and you always want to check that it moves freely, and you put your guard on, and then same procedure, of course, on the back side. It's a little bit easier to do this with two people, so you can have one person operating this while the person
One more piece of advice, of course, as you stand in front of the belt, either the front or the back, the belt always grinds from right to left. If you look in the feet direction, the front grinds right to left, the rear one grinds left to right, but as you stand in front of it, it always grinds right to left. So you want the abrasive obviously on the bottom, on the left side, so that when you grind, you actually remove material. And on the top, you want it on the right side. So you have to pay attention to the direction of your belt. Now we have the belts completely back on. This is a back belt. Of course, these are a little bit shorter, so we're going to have to adjust them further down. People always ask me, how do you know how to adjust them? I will show you that really quick. The fastest way to do this is to close your door. First of all, you bring it close, obviously. So we're going to come down. He's going to be sitting somewhere around 25 millimeters. You want to have this up and locked. We're open here. So, then you close the door. You bring the table to 0. We were wide open from the big piece before. So here's the table at 0. And you simply turn it on. And then you listen. As to when you hit the belt, which is right now. Then you open up the belt to your first material thickness. You start with 1.5. And you give it about 1.5 more cranks. Or 1 in this case. 1 more crank. So, and now we are going to run this again at about 2 feet a minute. You hear a different sound because these brushes are a lot more aggressive, of course. And you have more abrasive in engagement with the part. you will notice that we have a little bit more edge mounting on the outside here, but probably not as much on the inside contour. And that would be an argument for the standard block. The semi-solid blocks, the half blocks, are very aggressive on outside contours and remove more material, but they are not as aggressive on inside contours. So, this at 2 feet per minute, and these are the half blocks. Or we call them semi-solid, and this is obviously the drop side. The part has a little bit of a bow, and that has some influence, of course, also. You could always run it a second time if you wanted. The part ran like in this orientation, so now you would run it in this orientation, perpendicular, and then you would get to see significantly different results. And maybe I'll do that for you in that part halfway. So this once again is outside my logo 5 feet a minute. Go. So we're going to start this side here, and then we move from there. I need to pull this part out. So 1.5, 1.8, all the same. Round openings, because they're a little bit bigger, the brush can recover better. You will see a little bit more on the inside contour versus this one. Hard as it seems to be, this part produces less rubber on the part than the Scotch Brite block, the half block. So this is half block. I think you will like these edges very, very much. Here, because the openings are bigger, the half block really makes a difference. And it takes more of the tap. The tap isn't as pronounced on the outside with the half block. It's always a compromise, so you choose. See the distortion in the part gets held down by the pressure roller and then by the spring. But you're always going to grind that end very hard because it wants to push up into the brush. That's inevitable. Does a very nice job on the top of the tap. So, now all we do for the 2.5 from the cross side is we open it up a little bit here. We go to 2.5 and we go slow. So you see the adjustments for the machine for your different materials are almost on the fly once you get used to the machine and you know where the settings are. Which is a lot of it by temperature, what you feel by hand, the results that you see with your eye,
and of course what you hear also and how the run takes place. So that's 2 feet per minute. And then run. You probably could run this also. This is a very nice result. You will love this. If you wanted it to, you could run that probably at 3 feet per minute and get it very good result also. So I'm going to run this full speed at about 10 feet per minute, so you can see what that is. That's if you want to finish it up a little bit. So that's at 10 feet per minute on the top side. Right? And again, those were the half ones. Very happy with those results. Now let's move on. Let's do these real quick. Same thing. We go a little bit higher to the material thickness here. And of course, we need to bring our speed way down. Now we're going to go 3 feet per minute on these parts because they stand out a little bit thicker, and we're going to go to the burr side. I'm going to abbreviate HB. And then the other side, nice results. That means you will like the quality of those parts. And the other side, we're going to go to 4 feet a minute because it's not the burr side. Then the last that we have left to do, just this one. We need to remember not to make the same mistake, and then we'll just change to that. So that's 4 feet per minute. Half box. 4 feet per minute. Half. The half block is really aggressive on the edges, but not so aggressive on the surface. That is one of the key differences between the two. So, now here, again, we don't really have a burr side, so we can go 4 feet to 5 feet a minute. All we need to do is we need to adjust for the thickness. Here we go. So that'll be 4 feet a minute, and then the other side will do 5 feet. The thicker parts always come out good because you have full engagement on the edge. Super part. 4 feet per minute. In the end, you always want to run as fast as you can and still get a good result. A, because of throughput, and B, because of to minimize your media consumption. So, on the other side at 5 feet a minute.
see a little bit less radius here, but still very, very good. So, we'll start with the thicker side here, in order not to make the same mistake. That's at 5 feet a minute right now.
We have a good deburring at the end. This doesn't need deburring anyway, and you see we're not even touching the surface. So that's 5 feet per minute. That's long. And then we're gonna go to this side here.
Maybe we go 4 feet per minute here, and we need to bring it down to 9 feet. And that should conclude our tests today for this fairly diverse set of materials. All stainless steel, of course, but different in geometry. And in process, we had Waterjet, we had punching, and we had saw cut, and we had quite a bit of thickness variation.
See the edge in here, edge in here, looks good. So that was 4 feet a minute with a half.
Thank you very much.